Welcome back for this small recess, and now we'll move forward with David, who's going to be backdooring LLM, so I'm really interested in hearing. So, thank you.
Thank you. Hi, everyone. Well, thanks for having me here. It's my first time besides Lisbon, so really happy to be here. I had a bumpy ride this morning with a plane, so Lisbon is going through some strong storm. But it was good, and I'm excited to be talking today about how to backdoor language models and to bypass controls malware scanning on HuggingFace. So in this talk, it's a short talk, but I will try to explain how HuggingFace security controls work and what does it mean to backdoor language models. So when we talk about LLMs or SLM, like small language models, we always think about big providers like OpenAI, Facebook, Llama, Gemini, and more. But if we ask scientists or researchers that really develop those LLM and explore different LLMs or SLMs and try them more than once a day or try them continuously, they will think about HuggingFace. Now, if you're not familiar with HuggingFace, how can I put it? HuggingFace is the GitHub of LLMs. Or SLMs or models, data sets, so everything you need to pull a new language models or data sets or training data, you can find it on HuggingFace, and it's open source. Now, what is the problem with with open source? Open source is great, yeah, don't get me wrong. I love it, and we contribute a lot with different projects. But of course, when these kind of platforms, and we see it also with GitHub, become famous, well, they become famous also for attackers. So HuggingFace has been flooded with malware, and especially with malicious models and malicious data sets that were and are actually, because it's still happening, targeting developers or scientists or researchers or anyone that is pulling models, doing inference on their machine, and executing and using models on their systems. So, well, these are the guys behind the HuggingFace. I guess after those news, they don't look so happy anymore. But so today, I will try to give you a brief overview of what that means, how we can create malware to upload on HuggingFace. We can use it for different purposes, right? Well, we shouldn't upload malware to HuggingFace. Let's put that down. But if you are into red teaming, for example, that's a great way to maybe get your foothold inside a company. I didn't say that, all right. So just a few words about me. I'm Davide Cioccia, I come from Italy. I live in the Netherlands, and I'm the founder of DCODX. DCODX stands for Defensive Coding and Exploitation. We are a small cybersecurity company, and we love research. Now, you see my titles that I'm also CPO at SecDim. So SecDim, we provide secure coding training for developers and security engineers. And basically, how these two connects is that whatever we research at DCODX, we transform that knowledge into learning lessons as SecDim. About me, well, I'm a speaker sometimes, I try. And I also train at conferences like Black Hat, DEF CON, and sometimes at OWASP, you can find me there. And I'm also leading the DevSecCon Netherlands chapter. So if you don't know DevSecCon, it's meetup or conference that happens once a year where we talk everything DevSecOps. On the fun side, I love tennis and Padel. So I know you guys in Portugal play a lot of Padel too, definitely better than me for sure. Now, what are the security implications when anyone can publish models, for example, on HuggingFace, right? When models become open source. Well, the most obvious one is that if a model is tempered, of course, it can execute unwanted action. And the second implication is that we often trust models and data sets implicitly. So we use them, right? We pull them, we use them. Now, of course, it's very easy to use APIs to do inference on our models, but it's also very easy to pull models from HuggingFace and do inference towards those models. Now, the third problem is that models are most of the time black box. We don't know what's inside, right? How they were trained. We can't assess them. And the biggest problem here, and I'm going to talk a lot about this today, is that we don't have scanners. We don't have like SAS tools, SCA tools that are very effective against, against certain category of vulnerabilities, or we don't have malware scanners that are effective. I will show you what HuggingFace actually uses. They're almost non-existent. So the question is, and this is the title of the talk, how can we backdoor an LLM or an SLM or a language model, or even create a malicious data set that we can use to compromise a researcher machine? Well, there are two techniques, mainly. The main techniques that we're gonna explore today is the pickle deserialization, related to the usage of common libraries like PyTorch, NumPy, scikit-learn, but there are more. And other techniques that we're not going to touch today relate to TensorFlow and the Keras Lambda layers. All right, so I mentioned pickled. Now, if you are in application security and you love Python, you know what pickle is. But if you don't, pickle is a way of serializing and deserializing data. Now, pickles come with big problems, right? If we use pickles and in Python, we most probably are exposing ourselves to deserialization vulnerabilities. And with deserialization vulnerabilities, it means that we are exposing ourselves to command execution. Now, how models or data sets are shared on HuggingFace is, as you can see from the slide, through or via pickle, because models are pretty big, right? For example, I don't know how big is this one, but hundreds of megabytes. And before sharing a model with with the world, we need to serialize it. And you see that that model has an extension .b, so it's pretty much a binary. And whenever someone wants to try the model, they will need to deserialize that model. Now, in application security, we solved these problems with pickle a long time ago. We just said, hey, don't use pickles, right? So it went pretty well. Deserialization issues kind of became less and less, but unfortunately, now they're back. And why are they back? They are back because the libraries that we use to load models and to do inference on those models are based on pickle. So for example, this is PyTorch. If you're using PyTorch, then torch.load is definitely using pickle, is definitely doing deserialization of pickle files. And you see a big warning on all these libraries. I will show you a few more that says, hey, look, this library is using pickle, so be careful when you pull models. Now, I haven't seen, well, when these big warnings worked well, but PyTorch is not the only one, unfortunately. For example, NumPy .load NumPy is another library used a lot to create data sets, to share data sets. And it comes with the function .load to load data sets or to load models. And you see that the third parameter of this function is allow pickle false by default. That is good. But unfortunately, most of the models and data sets that are shared on HuggingFace are pickles. So in that case, you will need an allow pickle true, exposing yourself to malicious pickles and malware. One more. I don't know if you've heard about scikit-learn, or JobLib. Basically, scikit-learn is another library to load models and to create models that we're going to publish on HuggingFace. And the format that is used by scikit-learn is JobLib. Now, when we look at JobLib, it's kind of the same, unfortunately. Yeah. So joblib.load, in the end, uses pickle. Now, I'm mentioning pickle a lot, but I haven't told you how a pickle looks like. Well, like that when you eat pickles. But for example, XDump of a serialized pickle object looks like this. Right? It has a pickle protocol. That depends on the protocol that we are using. It stores the frame length, so the length of the payload, for example, the binary or the Python object that we serialized. And it ends with opcode 2e, that is the stop sign. Now, if we think, like, how do we produce that hex dump or that binary, right? That the content that will be stored in a binary. Basically, Python has two functions, dump and load. So with dump, we are going to serialize an object, and with load, we are going to deserialize this object to be used. And this is what happens in every library mentioned here, like scikit-learn, NumPy, or PyTorch. They use the load function and the dump function from Python to serialize and deserialize pickles. Now, how do we create a malicious pickle? This is, I think, AppSec deserialization vulnerabilities 101. But it's important to understand how we're going, what we're going to do later. So to create a malicious pickle, we can abuse the method reduce. So you see in the slide, I don't know which, in the class exploit, we have this function called reduce. And inside the function reduce, we have our malicious instruction. In this case, we are just running ID, so we're just printing the user groups. But you can imagine that you can put any Python code in there. So you can actually write your own shell, your own backdoor, and embed it in a Python object. Now, why is this reduce function important? Because every time we run load on a serialized object, on a pickle object, the first thing that happens is the deserialization will look into reduce to understand how to represent, what to do with that object. Right? So in reduce is the first function that is executed that helps the deserialization process to understand how to show the real object, right, the real data. And in this case, we are using it to basically execute commands. Now, you will say, okay, we create this malicious pickle, we upload it on HuggingFace. So what? Well, this is, as we saw from the news, is a big problem, and HuggingFace has been taking some remediation. So as part of these remediations, they actually included a bunch of security tools to scan every file that is uploaded on HuggingFace. You might be familiar with JFrog. It's vendor commercial tool. Protect AI the same. These are commercial tools that basically scan those files for, I will show you how it's done, but basically they actually implement a disallow list and an allow list looking for signatures. So we are back at 1980 when we're trying to writing antivirus with signatures. But one of the tools that actually I think it was maybe the second tool that was added by HuggingFace, if I remember correctly, is the last one. I don't know if you can read it, but it says PickleScan. Now, PickleScan is an open source tool maintained by one person. And it's used, and it was, and it still is one of the main tools that is used by HuggingFace to detect malicious models or malicious binaries, malicious pickles, malicious data sets. And the last one is claim AV. We're just going to leave it there. Now, how does PickleScan work? Did you watch this series? Do you know this series? No? Yeah? Yeah? Okay, cool. Yeah, so let me just try and see whether I can open this. No, I cannot. So, 1 second. Well, I'm trying to move my, here you go. Okay. Can you see this? Okay, cool. So I want to show you how PickleScan works and why I said that we're back at the old times when we were writing antivirus with keywords. So how PickleScan works is that it's basically trying to read the pickle files or the binary files and match malicious primitives that might be hidden inside those files. Right? So you can imagine that this doesn't really work, right? We experience it with malware. It's easy to bypass antivirus that implement signatures. And this is the same. This is exactly the same. So one of the biggest problems that HuggingFace is facing is that the security controls that are implemented are not really, really strong. So it's pretty easy to bypass them. And let me see if I can go back to the slides. I hope so. Let's see. Okay, this goes like this. Okay. Yeah. So in the end, it's a whole cat and mouse game. There is a new malware. There is a new dangerous pickle or binary or model that is uploaded to HuggingFace. Machines are compromised, and basically the signatures are updated. Now, one of the most recent incidents or ways to bypass these security tools and upload, valid malware on the platform is called nullify attack. And it basically, it's a very simple attack. I showed you how a pickle looks like at the beginning of the slide, like the hex dump that we saw. But what this attack exploits is the fact that these scanners need to scan valid pickles. Now, what researchers from Reversing Labs did is that they thought, okay, let's do like this. Because these tools actually scan the whole file, the whole binary to detect malicious activities in the language models or data set, why don't we change one opcode in that xdump and see whether we can bypass the security controls or the scans. So what they did, you see it in red down there, they basically changed one opcode from, it was 62 to 52. What does that mean? That means that the whole payload, the whole malicious pickle that contains our backdoor cannot be scanned because it's broken. So when we run those tools like PickleScan on this content, basically the tool will just raise an alert saying, hey, the pickle is broken, or even worse, it will say it's not a pickle. But actually when we're going to load this one, and I will show you if I have time as short demo, when we load this blob, this binary, using one of those functions like numpy.load or pytorch.load, it will execute the malicious codes that we embedded in it. Oh, there you go. Not sure it's readable, but this is an example of what happens with the broken pickle. So when we try to load a binary that contains the XDAM that we just saw with one flipped opcode, well, you see that the command is still executed on the machine, right, when we run it on load. But actually, the library will return an error saying, like, okay, this is not a valid model, this is not a valid file. But unfortunately, we are already able to compromise someone that loaded that model or pulled that model from HuggingFace, for example, or from any other vector, right? And this happens because how Pickle works is that they are read, the file is read in sequence, starting from top till the end. So this flow breaks only at the end. So our payload, our malicious payload, is most probably in the middle, and it is executed. Now, as I said, right, whenever there is a new bypass, Pickle scan is updated, or all of those tools are actually updated with those signature. But there is much more to research. So, and this is what we're doing at DCODX and at SecDim. I want to share with you, I don't know if you know Hunter, but basically they have a bug bounty program if you are into bug bounties. And they recently launched a category that is compromise models. And if you can find a way to bypass the security restrictions, security controls, security scanners on HuggingFace using one of those techniques, well, you will get a bounty, of course. And you see, there is much more. There is much more. It's not only about the model, but it's also about the libraries that we use. I think in the previous talk, you mentioned that things are evolving very fast, and actually they are. And also, all the frameworks, libraries that are used to load models, to use models, are changing continuously. So definitely, it's a green field for bounty hunters. Now, I promised in the description of this talk that I would share some CVs, well, 2 CVs. Unfortunately, I will share only one because the other one is still not public. Let me, okay, this is, I'll try to do this. I cannot. One second. All right, so this is the Pickle Scan project. As I said, it's an open source project. It's on GitHub. Right? Is the maintainer here? No? Okay. It's on GitHub. So it's an open source tool that is used to pretty much detect as a backbone of HuggingFace. And as you can see, the security advisory is growing. It's growing quite a lot. When we first reported the issues, we were here. So we were the 1, 2, 3, 4, 5, 6, 7th, right? So what we did is, so Pickle Scan is pretty strong in detecting common execution threat, but it was not too good at detecting data exfiltration threat. So most of the times when we create a backdoor or we want to compromise a machine, it's not always about the ability of executing commands, but actually exfiltrate data that can bring us to new avenues or escalate our privileges. So just to show you the POC that basically resulted in the CV. In this POC, we we had to use, well, we had to be a little bit creative and find primitives that could allow us to call an endpoint and load or read a file. So we identified the, let me see, the primitive line cache. Do you know it? Familiar with it? We weren't either. To read, for example, the etc password file, and then we had the other problem. Okay, we can read a file, but how do we exfiltrate it? We cannot use HTTP request. We cannot really use the common libraries in Python. So we decided to give it a try using DNS. And we were actually successful in basically using DNS calls to exfiltrate data. So at the end, we put everything in a binary file. We uploaded to HuggingFace. No alerts. Everything looked green, fine. And, well, it gave us a bounty. Now I cannot share the other CV because there is no CV yet, but it's still in under approval. One second. As you can see, I'm struggling with the monitor. So how do we defend ourselves? If we are using HuggingFace, if we are using models, if we are trying small language models, why not? Well, the first thing, of course, is the same advice that we had in AppSec a long time ago. Pickle is broken by design, so don't trust, models implicitly, right? So make sure if you can assess it, if it's a pickle, you can see what's inside. Do that. Pickle scan is not really trustable, so don't rely on it. HuggingFace doesn't, as they're adding more and more tools. And if loading pickles is needed because a model that we want to use maybe is pickled, then is published, then make sure to use safe load. So newer libraries implement better loading methods. And the last thing is, well, HuggingFace comes with a function that is called from pre-trained that is safe by default and allows you to pull in and do inference safely on models. Now, well, right on time. That's all I had to say. So if you wanna be in touch, that's my LinkedIn, email, Twitter, still call it Twitter. I'm nostalgic. So feel free to send me a connection or, if there are any questions, happy to answer. Thank you.
Great presentation, thank you. And how was the DNS exfiltration? How did it work, actually? How did the DNS exfiltration work?
Oh, the DNS exfiltration. Sorry. So the question, how did the DNS exfiltration work? We basically send a TXT record towards an endpoint, and we had to normalize the content. So in that case, we read etc password, for example. We had to normalize, we had to remove all the semicolons and replace it with underscore, make it one line. So basically, we had to exfiltrate line by line the whole content of the file in that case.
And it would go to your DNS server, right?
Yes, we will. Yeah, it was towards our controlled DNS server.
Hello, thank you for your presentation. Do you have any opinion about using deal, safe tensors called pickle? Do we all suffer the problems from pickle? Or like safe tensors or deal avoid as dealing with pickle directly, thus avoiding us to having these kind of vulnerabilities?
Wait, if I understood the question,
Yes, there are other serializing libraries for Python like
Yes.
pickle, deal. Pickle is one, right? You have deal as alternative, and HuggingFace now are using a lot of safe tensors to make serialization, deserialization. If you have any thoughts on that, did you dig if safe tensors actually solve the problem? They don't. If you have any thoughts about safe tensors or even deal or cloud pickle.
yeah, I mean, all these libraries are using Pickle. Like, what we see is that PyTorch maybe is the most used one, and it's, well, the load function is definitely vulnerable, but newer version, as I mentioned, are providing safer ways of loading Pickles too. Like, most of the time, you don't need to expose yourself to deserialization, and with newer frameworks, of course, this is not really an issue. The problem is that when you use, for example, PyTorch to create your binary, then in that case, well, the best way to prevent it actually is awareness towards like the developers and well, using, if possible, the safe load alternative. So that will be.
So thank you. We'll need to move forward. So I think David will be happy to answer any first questions.
Definitely. Thank you.
Thank you.